Hello everyone, welcome to switispeaks official YouTube channel. I am Sweetie Pinjani. Today we are going to discuss major enhancements in System Verilog compared to Verilog. There are a lot of enhancements. We will discuss the major ones due to which we prefer System Verilog over Verilog. There are a lot of important enhancements which System Verilog has provided us. Let's understand them one by one. The first enhancement will be with respect to data types. We are going to see what are different data types which are introduced in System Verilog that were not available in Verilog. And then there is interface. We are going to see what this interface is. This is a new concept provided by System Verilog. There is OOPS. This was not there in Verilog and it is one of the very important concepts in System Verilog which makes it reusable. Next thing which we get in System Verilog is randomization. Very important concept used by the verification engineers. Then we have coverage and we have System Verilog assertions. Let's understand each of these one by one. First one is data types. There are a lot of important data types which System Verilog provides us which were not there in Verilog. For example, the first one is arrays. This was not there in Verilog. And in System Verilog, you have different kinds of arrays, like you have packed array, unpacked array, dynamic array, associative array. There are advantages of each and there are applications of each. For example, if I talk about dynamic array, the size of the dynamic array will be decided at runtime. If there is a case wherein you are not sure about the size until runtime, you can use dynamic array. Like this, there are a lot of different types of arrays. We have seen all these different types of arrays in System Verilog tutorial series. If you want, you can go through. These are very important data types which were introduced in System Verilog and we use them a lot. The next one is queues. The specialty about queues in System Verilog is mostly due to a lot of inbuilt methods. If you go through System Verilog tutorial series, you will see a tutorial on queues where we have discussed this data type in detail. The inbuilt methods in the queue make it very useful in System Verilog. Another data type which was introduced in System Verilog is logic. The specialty about logic is it is a four-state data type. It means it can take values 0, 1, x and z. It can take unknown as well as high impedance values. This is one specialty of logic data type. It was not there in Verilog. Then we have enum. I can give you one example wherein enum can be useful. For example, you have a state machine. Now, at a time, you will be in one state. You can't be in multiple states at a time. For example, initially I'll be in idle. Then say I'll go in some other state. Then I'll go in some other state. At a time, I'm only in one state. And I can assign numbers to that state. For example, I assign 0 to idle. Then the next state, I assigned value 1 and so on. Enum is the data type which can be used in such scenario. You can assign values to the name. Then we have struct. Here, if you have different kind of data types which you want to bundle together, you can use struct. For example, in a packet, I can have a lot of different kind of information. I can have data, I can have read, write, and they can be of different sizes, different types. Something can be of int, something can be of bit, something can be of 32-bit value. Different kinds of datas which are combined together, bundled together. That is called as struct. If you want details, you can go in System Verilog tutorial series. All these data types are there in System Verilog, which were not there in Verilog. The next important enhancement in System Verilog is interface. You have a design under test and you have a test bench. You need something to bind them together. That component which binds your design under test and test bench together is called as interface. It is used to connect your design under test to test bench. Interface is just a bundle of signals. It will have the signals which can help you connect your DUT to the test bench. Interface at one end will be connected to design, and at the other end it will be connected to test bench. And through interface your design will interact with test bench and test bench will interact with design. This is the main role of the interface, which is introduced in System Verilog. Next very important thing introduced in System Verilog is OOPS. We have a complete series on System Verilog OOPS in switispeaks official YouTube channel. If you go through, there we have discussed OOPS concept in detail. The major attractive feature of OOPS is reusability. It helps you in reusability. You don't need to write the similar type of code again and again. How? That you can go and understand in detail in OOPS series. There are a lot of concepts like inheritance and a lot of other concepts like polymorphism and other things which makes OOPS reusable, which is very much needed in today's complex designs. Next important feature which is very much used by verification engineers is randomization. There can be thousands of signals in my design, and those thousands of signals can take a lot of values. But in the real life scenario, not all values are possible. For example, say I have a register, 32-bit register, but I am using only 8 bits for now. Other fields are reserved. So changing values in other fields will not get anything, and it will not help me in testing the design. It's of no use. I should only focus on the 8-bit value. Such kind of things you can write in your constraint, that you should ignore those other bits and you should only focus on 8 bits. This is just one example. Again, there is a complete series on constraint randomization because it is a very important topic in System Verilog. We have a complete series. You can go through it and you will understand what is this constraint randomization and how you can create a constraint random stimulus to test your design. Very important topic in verification. Next important concept provided in System Verilog is coverage. I have a very huge design. How will I know that I have covered everything? I have tested everything in the design. I need to do some coverage. Now, this coverage can also be of different types. There can be functional coverage, which tells me what functionality of the design I am testing. Here we write the cover groups and cover points. We write a lot of different things. We will have a complete series on System Verilog coverage where we will discuss all these things in detail. For now, remember that the functional coverage tells you how much functionality of the design you have covered. Then you will have code coverage, which will tell you how much code of the design you have covered. For example, how many lines you have covered, how many branches you have covered. If there is a FSM in your design, how much of FSM you have covered. Code coverage can take different forms like branch coverage, then as I said, line coverage. And another thing in code coverage is toggle coverage. For example, I have a 2-bit signal. It can take four different values, right? 0 to 3. And again, each bit needs to toggle 0 to 1 and 1 to 0, 0 to 1 and 1 to 0. That is the toggle coverage. Toggling of the bits, toggling of each bit. This is also very important part of the code coverage which we consider. Then we have assertion coverage. Assertion is very important nowadays. It describes the behavior of a design. Say, for example, I have a design spec which says whenever I have the request, within 5 clock cycles, I should get the grant. This becomes the design behavior, and I can write an assertion to check this design behavior. We again have a complete series on System Verilog assertion. If you want to go through, it will help you understand what are assertions and how we use it. You should go through it because it is a very important topic nowadays in System Verilog. Then System Verilog assertion itself is a new concept, and there are techniques which are completely based on System Verilog assertions. For example, there is a verification technique called as formal verification, assertion based verification, which are completely based on System Verilog assertion. It is such an important topic. And I have seen books, thousands of pages of books written only on System Verilog assertion. It is such a detailed topic, and assertions are very powerful. Again, I will recommend you to go through the System Verilog assertion series because this is an important topic. You should add this skill set in your profile. It will help you. It will help to check the design behavior. As I gave you one example, the spec says if the request is there, you should receive grant in 5 clock cycles. That can become a design behavior which you can check with the help of System Verilog assertion. Like this, you can write assertion for very complex behavior also. We are going to discuss this in System Verilog assertion series. These are the major enhancements in System Verilog.